On full moon nights, according to Korean legend, a creature emerges in the shadows, the Gumiho, a nine-tailed fox that has lived for 1,000 years. It possesses the power to transform into a beautiful woman, but harbors a dark secret. It must feed on the heart or liver of men to maintain its human form. However, in that crucial moment between temptation and redemption, the Gumiho must choose: devour its prey or spare its life and lose its power. Today, through motion engineering, we have recreated that instant of dramatic tension. I am Luis Miguel Fuentes, and together with my colleagues Santiago Beltran, Camilo Gonzalez, Santiago Torres, and Daniel Valenzuela, we present our Automaton inspired by the legend of Gumiho, developed under the guidance of Professor Miguel Fernando Montoya in the motion engineering course. The Gumiho Automaton features three main developed movements. The first movement represents the head movement, achieved through a gear mechanism, where continuous rotation is transformed into an oscillatory movement, developed along the z-axis. The second movement is the opening of the mouth to devour a man, developed along the z-axis, produced by a cam and follower system, generating an opening and closing movement that represents the doubt and internal conflict of the Gumiho in its crucial decision. And the third movement is a complex movement, which will represent the scene of a man's death due to the Gumiho. This movement will be present along the z-axis and the x-axis, symbolizing that eternal cycle of temptation and resistance that defines the Gumiho in its quest to become human. The transmission mechanism consists of two key parts. The initial part is built with a gear train, which transmits the movement generated by the motor that will be located at the rear of the box to the different mechanisms that make up the project, thus having two movement outputs with different ratios. The first output has a transmission ratio of 4.4, and the second output has a ratio of 6.8. In this order, the first output connects with a head movement system, which is formed by two bevel gears that have a ratio of 2, used to change the axis of rotation of the system, connected with a wedge which generates an oscillating movement, allowing the turning movement of the fox's head to be generated. The second output connects to the camshaft, allowing the movement of this mechanism to be maintained, resembling the vertical displacement that the jaw would have when opening and closing. Here we can see the equations used to determine the displacement. Additionally, for the complex movement of the body, we use a 4-bar mechanism of the crank rocker type. This system is composed of a 15mm crank that acts as the driving link, a 34mm coupler, a 30mm effective link, and a 34mm fixed link that functions as a fixed structure. By applying the Grashof condition, we confirm that it meets this condition, allowing the crank to complete full revolutions. According to Barker's classification, since the crank is the shortest link and is adjacent to the fixed link, it is classified as a crank rocker type mechanism. The Automaton's components were manufactured by combining two complementary manufacturing technologies. On one hand, 3D printing was used to create the characters of the Gumiho and the man, along with two bevel gears necessary for changing the direction of movement. On the other hand, laser cutting allowed for the high-precision fabrication of the flat pieces that make up the mechanical structure of the project. Together, these two technologies enabled nearly 100% of the mechanism's fabrication to be carried out. For the design of the three-dimensional components, we used artificial intelligence tools. Finally, here you can see our prototype in operation. Next, you will see the physical prototype in action, where all the movements come to life. The Gumiho's head turning in an internal tension, the jaw opening and closing in its conflict of devouring or sparing, and the complex movement of the body recreating the dramatic scene. In this way, motion engineering transforms a 1,000-year-old Korean legend into a mechanical reality that captures the emotional intensity of this crucial moment. Now you know, nothing can stop us with engineering.